So my name is Jorman. I work for GoDaddy. I am a software engineer. I actually joined the company this year after an acquisition of another company. I came to Vancouver this year because I want to learn about mobile development, but I've been doing mostly backend development. You can see some keywords there in the slide. I have worked with DNS, TLS, some parsers, and random stuff. So the presentation is about Go. Go is one of the most used verbs in English, but this is not a presentation about English. This is a presentation about the Go programming language. The problem is that on Wikipedia you can find two pages called the Go programming language, one with an exclamation mark and another one without the exclamation mark. The presentation is about the second one. I'm going to show the slide later. There was a confusion at the beginning of this language when it was created, because there was an author several years ago who started this project. Like, he had experience on building compilers. So he created this programming language called Go exclamation. And then Google, three engineers, one of them you may have heard of it, Ken Townsend. He was part of the Unix operating system. Rob Pike and Robert Riesemer. They were working at Google at the moment. They are still working there, I think. They decided one day to start talking about how could they improve their development process. They are mostly C or C++ developers, and they realized that C++ were very cumbersome to develop with. So they started to come up with ideas. After some time, they developed a prototype for Go. They wanted to come up with a name, and the first thing that they come up with was Go. Then, 2 years later, they found this guy, and he created a complaint. This was actually on the previous Go source code website. It was later migrated to GitHub, and he left this comment asking the core Go developers to change the name, but as you can see, it was marked as unfortunate because they didn't want to do it. So anyway, so Go was created, I already explained that, mostly because they were not pleased with how C++ allows you to develop programs. So they wanted to come with more ideas. So they mixed some features from other languages, mostly Algo, some C, some other languages that are not here and I don't remember right now. And here is a list of features, or not features, but aspects of Go that makes it famous for. I am going to explain a little bit of everything in the next slides, but you can see the list there. So the first one, solid standard library. The first thing that you will notice when you talk with a Go developer is that if you are a web engineer or a software developer, you will ask them, oh, so what is the most famous framework, or what can I use to start my own project? And they will immediately tell you, you don't need a framework, because the standard library actually provides you with enough tools or enough libraries to come up with some project. You can notice that at almost at the end, where it says runtime below, there is a list of sub packages. There are two of them that are very useful if you want to go even down to the computer. One is cgo, and the other one is at the end, unsafe. So this is because Go is by itself a garbage collected, but if you want to do your own memory management, you can use those packages, and there's a lot of things for HTTP, some protocols, mail, RPC, encoders. Another thing from the list is monolithic repositories. This is something I don't really know how to explain it. I will try. So the idea came from Google. They have one of the most biggest monolithic repositories in the world. Right now, actually these numbers are from last year. They are sharing a very big repository among most of their software developers. And because these creators of Go, they work there, they kind of share the same ideas. So they decided to create this environment variable, Go path, and Go root. When you install the, how to call it, like the packages or the compiler, in your computer you will have access to a directory path, and this is going to be the Go root. But in the directory that you choose to work in your projects is going to be on Go path, and you have to set this variable. This has been there has been a discussion between people who are new to the language. They don't like to do this, I don't know why. So this year they decided to change the installer to automatically set the path to be home Go. So you only need to create this directory. But virtually speaking, technically speaking, you can just put Go path to any directory in your computer. By default is this, but you can create different folders for different projects. You don't actually need them to have in the same tree. But that's the idea, because Google likes monolithic repositories. The next slide is about the built-in testing package. Actually, there are many languages that provide this by default, but Go is also famous for this. There is well, in the solid here, there is one of them is testing. I don't see it, but it's there. You can just import this package and have access to a unit testing suite. The package also provides some methods that you can use to benchmark your code using normal benchmarks in parallel. You can create subtests. The package in itself is very powerful. There are 3 points in this slide that I am not actually going to talk about. The idea at the beginning was to make a demo, and in the demo I was going to explain it, but I had to switch computers at the end, so maybe I will not be able to explain it. I will try to explain the first one, concurrency. So I'm going to jump right now to Moore's law. So when the creators of Go started the project, they had this law in mind, or concept in mind. For several years, we have been noticing that companies who make CPUs, they have been kind of doubling the amount of transistors in every unit, almost 2 years, actually almost 18 months. But in 2005, this stopped, and I don't know how to explain it. They stopped, and now they are adding more cores to the computers. The problem is that the languages that were invented before this year, they didn't take advantage of this, or they didn't have this in consideration, because the idea was that, oh, every 2 years we are going to have more transistors, so there's not a problem. We had access to threads for older programming languages, but now, actually I'm going to explain that later. Let's just end this here. So there's more core. We don't have more, we only have cores. This is just an overview of what I said at the end. You can see what they actually propose. So by design, the language is taking advantage of multi-core architecture or machines. I am going to jump ahead. I'm going to make a parenthesis here, because in my presentation, you can see one bullet point almost at the end. It says, we're object-oriented programming. Go is not really an object-oriented programming language. You can do it, but it's kind of weird, and you can see it in this example. So this is basically what you can do. There's no really a concept of inheritance or encapsulation, but you can do some basic stuff. So you can just define a custom data structure. You can attach methods. That's basically what you can do. You can actually share some data between them if you add the asterisk. If you convert this into a pointer, and then you can, if you take this object, the one that is at the beginning, and you have another one, let's say foobar, and it has some properties, you can actually put the name of foobar inside the curly braces of the first one, and then it will kind of inherit these properties. But you can see that it's kind of weird. But if you like object-oriented programming, this is what you should do. Okay, so this is a graphic representation of why there's no object-oriented programming. So for several years, Go developer has been asking the core developers to implement generics. They don't want to. This year, they are in version 1.9. They are going to jump to version 2, I think, next year, but they already opened the proposals this year. So if you like Go and if you need generics, please talk to them, send them use cases. They are actually waiting for them. And when they have actually a real list of use cases, they will come up with an idea of how to implement generics. But the idea is that they don't want to implement something that is not clear at the beginning. And apparently no one have given enough proof that we need generics for the language. There is something else in the presentation. The last one is try catch, exceptions and errors. So in Go, we don't have exceptions. I don't know how to explain why. I can just show the code. So the idea is that you want to read, most of us, or nowadays, most of developers read more code than writing. So if you read this piece of code, you automatically know what is happening. You are opening a file, checking errors on opening, deferring the closing method. If there is an error, you actually act on it, and then use a buffer to read the content of the file. You know what is happening by reading this. If this was in Java, for example, you would get exceptions, and you will have to put try catch and a lot of stuff that it will force you to jump into other files to know what is actually happening. So that's more or less why they did it. But they didn't provide a real explanation. They just did it like this. You can notice the defer function. This is also something weird. At the beginning, most of the examples that you will find on the internet, and the defer function doesn't act like this. It's not an anonymous function. It's just defer and then a function call. But there are some function calls, at least in the built-in packages, that return an error. Many Go developers, or at least beginners, they don't remember to check them. And this is a reminder that you should do it. It's very verbose, but not like Java. But it's because we want the person who is going to read the code to actually understand what is happening, that we are actually handling all the errors and that everything is happening in a sequential way. Here are more points. Actually, I should have shown this slide before. So this more or less explains why errors are more important, or why the concept of errors is better than exceptions. Basically, the idea can be summarized in the first sentence. Errors in Go are actually values, and you can program them. Yeah, that basically summarizes everything. And you should always check them. So sometimes in Go, you can actually, in the first line, you can see that there is a method that returns more than one value. You could ignore the error and put just an underscore instead of the ERR at the end. But then it's kind of weird. It's like if you use code in Java and don't check for the exceptions, and then end up with a big try-catch in the main function. Okay, let's jump ahead. So this is more or less the sentiment that many Go developers have at the moment, and many beginners. They see this if our error is not null, then do something. You will see it everywhere. And people at the beginning think that is kind of weird. Okay, who uses Go? Obviously Google. Google have used it a lot in their servers. There's many projects that are very popular. Docker uses it. More than 1,000 companies. Actually, the list is bigger, but they are the ones who want to go public. So if you are a Go developer and your company is using it and it's not in the list, please update it so people like me can apply to your company. Last year, the team that is in charge of the marketing or the development of the language, they released a survey. So people who use the language, or even as a hobby, they can answer some questions so they can focus on developing some features or marketing some content or explaining some things. In this survey, there's a lot of data. I couldn't summarize it very well, so I just took one of the first things that came to my mind, is that more than 500,000 developers around the world are using Go. So there's many. So if your company wants to use it, please advertise it. So again, people like me can apply to you. There is also some statistics about that survey. There is the link at the end. I may share the slides at the end of the day. If you want to read it, please. There's a lot of data, interesting data there. You can see that at the beginning, I explained that the idea was to catch the attention of C developers when they started designing, when they started designing the language. But today we noticed that many scripting programmers, right, Ruby developers, JavaScript developers are actually switching to Go because of the performance and the simplicity of the language. I have to jump ahead because I ran out of time. So this is another thing that makes Go famous, the mascot, just a gopher. Goroutines, I wanted to explain this very well, but I ran out of time. So goroutines are basically lightweight threads. I will explain it very fast. So in a computer, you are limited by the amount of, let's say, memory. You cannot go to a very long extent to create threads, while a goroutine is actually virtually unlimited. You actually start with a thread, and then as long as you start getting, you can feed more goroutines, millions of goroutines. You cannot do that with threads. And when this thread blocks, the Go runtime automatically creates another thread, and it uses this with the other goroutines until they unlock, and then it goes back to this one. And this happens automatically. You don't have to care about mutex, but there are some primitive, like the sync package. You can use it if you want to lock and unlock your program by hand. There's also a primitive called channels that you can use to communicate between goroutines, so you can transfer and receive data. And compared with threads, firing up a goroutine is way faster. With a thread, you have to take in consideration the stack size, while with a goroutine, it only takes like a few kilobytes because of the way that I explained how it works. This is when I was going to do the presentation. However, because I don't have my computer, it's kind of difficult, so maybe I can just show you a little bit of code. My idea was to create the web API with this code. The only thing that is missing there is the method. I don't know if I have time for this, but let's create it. Okay, so here we have an API endpoint. So when you run this, it will open this port 8080, and when you access the root URL, you can put anything else. It will go directly to here. My plan was to import the package time, so I could put like a sleep here before the response. Let's wait, for example, 5 seconds. So if I execute this code and I finish the command line interface, let's suppose that it's finished, and I execute this, for example, if I feed the program 5 times, then it is going to wait 5 times. 5 times by the amount of time that I call the API. So if I call it 5 times, it's going to end up with, if I call it 10 times, it's going to end up taking almost a minute, 50 seconds. However, if I call, this is because of the for each is doing it sequentially. But if I add a keyword, so if I do this is more complicated at the end, it's going to do it everything at once. The problem here is that this is going to behave the same way as you execute a command in Unix, like command ampersand. So the program is going to finish, main function is going to finish, but these programs or goroutines are going to keep running on the background, and you are not going to wait for their response. So what we can do here is go back to the top, import sync package. Let's instantiate this here. This is actually a pointer, I think. Sorry, I don't remember if it is like this or this. For every URL that we are going to receive from the command line, we are going to add it to the wait list. Then we are going to wait for all the goroutines to finish. And then we are going to create an anonymous function and pass the wait list. And then when this sequence of code finishes, we are going to call done. And that's it. So now, if I call this program, well, it's not finished, but if I call this program 10 times, it's not going to take 50 seconds, but just 5 seconds, because every HTTP request to the web API, which takes 5 seconds, because we put this sleep, they are going to do it almost at the same time. Maybe with a delay, but depending on the latency of the internet, but because this is in the same computer, this is going to take just 5 seconds, not 50. And I think that concludes my presentation. You can read more about Go from these websites. There is a tour. You can learn the basics and contribute to the language. Thank you.
Hey. Ooh, you should stay up here for a second. Typically at this point, we have like a brief question period. 3 questions. Are you okay with that, Yerman? Yeah. It's a free-for-all. So anyone who raises the hand, you can ask a question. But we limit it to 3 because we do have someone else who needs to set up. Cool. Question in the back, center row.
In your personal opinion, what are the limitations of Go as it stands?
The language in itself is very simple, so you have to come up with very clever ideas to find a solution that in other language you could do it because it's already done. The language is very new, so there's not much in the wild that you can reuse. So most of the projects that are popular right now is because they are made by people who have a lot of experience in the field, in other languages. So if you were to find a library made by me, don't trust it.
All right. Another question. Okay. Go for it.
Are you going to be putting up your slides somewhere where we can look at them later?
Yeah, and they are actually on my website. Actually, if you go to sigstore.com/a.key, it will download the presentation.
We'll try and put it up on the Code and Coffee channel too. If you tweet it, we'll just put it out there that way. Yeah, perfect. One more question, last one. Okay, there you go.
To use it for what? No, really, it's not specific to that, but there are some libraries that are made on Go. I mean, they are ported into Go, but I don't think the language is marketed for these specific projects. Yeah. Oh, by the way, maybe now that you mentioned that, there's also, to add more to the confusion, there is also a popular game called Go, a Chinese game called Go. So it's going to be very difficult for you to find information. So if you go to the internet, please be sure to use this keyword. And if you are going to ask for a library, use PKG, and that's it. Because it's very difficult to Google Go on Google, even if the project is from Google. Thank you.
Thanks, Yerman. A round of applause, please, before. Okay, yeah, I'm going to move it. Give me a second.
Hello. Hopefully this actually works. I made like a command sequencer to sudo live code. So I'm gonna be building a JSON parser in PEG, which is a parser generator language. So let's just start out. Oh, ignore some things. So a valid expression in JSON is just the null keyword, but it doesn't exist because I don't have anything yet. So this is really basic PEG parser generator. So the first line of any PEG syntax file is the entry point for the syntax, and then you can basically give it like a sequence of other things to run. So in this, it's gonna just only use the null type. So if I save this, that's now valid. But this syntax only understands null right now. If I try and do like true, it's not gonna work. So let's add a bool type. We've now added this slash thing, which indicates that this type is either this or this. You can have like composable things. So we have true, and we have false, but also numbers don't work. So let's add some numbers. So here's a super naive one. It has some bugs. Can you tell what they are? So we can parse a number. We can also parse that, which shouldn't work. So let's fix that. Okay, so this is going to match anything that starts with 1 to 9, and then any number of digits, which is defined by this one here, which is 0 to 9, and any number of digits. So this will actually recurse, and the question mark indicates that that part is optional. So this will just keep recursing until the second part doesn't match and stop. So it can have like any number of 0 to 9s. Mute my phone. So this will match, the first part will match like 1 to 9, and then any amount of numbers. The next one will match just 0 to 9. So those are valid basic numbers, so that's not going to pass anymore. But that will. But negative numbers don't work. So let's implement that one too. That was easy. So we just have this little optional negative sign, and it just works now. So now let's implement decimal. So we switched this to float, and now added this optional decimal thing. So the whole rest of this will still work the same. It just might have a decimal. And parse float just understands that, so that's easy to deal with. So no, I need to save my syntax. So that works now. Now let's add exponents. So the I indicates like case insensitivity. So uppercase and lowercase e is valid in JavaScript number syntax. And then this is a sub-expression that you can have it like match the first one or the last one, and this will actually map to one like subcomponent of this parser. That'll matter later, but overall the whole thing is optional, and then a number after. So we can have like keep forgetting to save. We can have that. We can have that. We can have that. All of those work now. So let's move on to a new thing, strings. So that's really basic, but actually broken. Can you guess how? Let's give this a try. So it expected a double quote, but ran into the end of the input because this is greedy. So the dot is going to match any character. Same sort of thing as regular expressions, if you're familiar with that. And the star is going to match just any number of whatever it's modifying. And so that's going to include double quotes. So we need to tell this to not do that. So we use this sub-expression that if you have the exclamation mark followed by an expression, it will negate but not consume that. So it'll see this next character is not a double quote and then apply the next thing, but it is anything that matches after my other negation. So this will work now. Except there's another issue. So we have this like really weird structure. So the way that the parser generator is going to work is like each sub-expression is going to like return its own component. It's like this first one, like we have an array. The first one is this single quote. And then the next one is weird. We have this like array with a missing element and then a letter, because this star indicates that there's like a whole bunch of things. So it's going to form an array of these. And the negation, even though it is like negating a thing and not actually consuming anything, it still creates an element. It's weird, but it does that anyway. So we can name sub-expressions and return those. So now we get the thing we needed. So let's move on. Arrays, those are fun. So an array is just square braces containing possibly a list of elements or possibly nothing. So this is going to use the optional thing again to indicate that this later elements expression may or may not occur within it. And then within that, we have, this is a common practice in most parser generators, that you'll often encounter situations where you have like a separated list of things, often comma separated. So you'll often have a head value that is usually guaranteed to be there. Like in this case, we've made the whole expression optional, so either the entire thing doesn't run, so we don't need to care, but it might not have a value. So if it actually is valid, then we're guaranteed to have this value. And then we have the tail, which, again, this has the sub-expression. It has this first component, which is going to like form into that array thing it's going to build, and then the value after. So we have this head that is a valid value, but we have the tail, which is like an array where the value is the second element, and it's weird, so we need to like decompose that into something useful. So let's write this handy little function. So you can use these curly braces at the start of PEG to insert any helper code you need to compose things. So here, we're just taking the head, putting that in an array, and then flattening the tail into the array as well, and just like mapping out the second element of each of these tail items, which points to that value. That'll create the array that we want. So that works. Let's move on. Let's create some objects. Those are fun. So here we have a new pair type. So an object is structured similar to an array. It's enclosed by curly braces instead of square braces, and it's a comma-separated list, except it is not a separated list of individual values. It is a separated list of key-value pairs. So we created this pairs type, which we can put into this list, and each pair consists of an array with this key-value mapping. You could form an object here or an array, whatever works for you, but I chose to do it this way, and I created this new from pairs function, so I need to put that in there. So that's just going to create a new object and then loop over this pairs list, which we're going to create the same head and tail list we did before for arrays, except each of these items is going to be one of these. It's going to be this key value pair array. So we need to take that array and destructure it out. and grab the key and value and store that into this new object, and that's going to return this object we want. So now we can have objects. That's pretty cool. So one thing that most JSON parsers have, though, that this one doesn't, is we can't actually put spaces around things. It's going to blow up. So let's fix that. So I'm replacing all of the existing occurrences of the value, used to be values here and value there, with this new expression which replaces the original top-level value type, and it puts this white space thing around it. So anywhere that a valid value can appear, it can also have white space around it. So now that works. So it's super composable, just being able to like compose all these little mini parsers together like this. So this is basically valid JSON right here, but that's boring, so I'm going to do some more stuff. Let's add single quote strings, because why not? And this actually works for keys automatically too, even though I didn't do anything special for that. But let's also make quoteless keys, because you can do that too. That works. Now for the fun part, comments. Everyone hates that JSON can't support comments in this. Who knows why? Whatever. So I made a parser that can do that. So let's just put a comment in here, because I can, and it still works. So all of this composed pretty simply, and I was able to like just insert these like very simple micro parsers inside of other things. This comment I can just stuff in the white space, because a valid comment can appear anywhere a valid white space can appear, and so like you can just compose a whole language or like parser for anything out of just all these little mini parsers. It's super simple to understand. So I will also show line comments work too. Oops. Might help if I actually type it right. So it parsed that properly, because it pulled the line comment out of it. So yeah, the parser it'll basically just run like each of these individual like mini functions, and sometimes it has like these like return functions to like tell it what to do. Up here for numbers, I used the text function, which like is specific to PEG, but most parser generators have something equivalent to that. That this is just grabbing the whole text of like the entire line. There's some special stuff I did, like here in characters. This $sign before an expression does basically the same thing of whatever is in that expression. It's like the text thing. So like you might remember that in a couple places we had this sub-expression with the negation, and then matcher after it produced that array where there's like an undefined and then the value after that. So this will actually just flatten that out. So that undefined and weird array thing just disappears. So we can just use the characters thing directly. So yeah, that's a JSON parser written in like a couple minutes. Yeah.
Question time. Yeah, 3 questions as usual. I thought that was a hand, but there's one right here. Go.
Yeah, some of this stuff can be done with regular expressions, right?
Hmm?
Some of those things can be done with regular expressions too. Like some of those they're not. It's pretty like there's a pretty blurry line. Like do you have a good rule on when you would need that or writing a
Well,
regular expression?
generally, parser generators are actually just composed regular expressions. Like a lot of this, like that is actually just regular expression matching, and like that there. And so like parser generator just makes it simpler to like repeat things. Yeah. Yeah. Well, nice-ish. Some of them were not great, but yeah. With Regex, like if you're trying to implement something fairly complicated, it can very easily blow up to being like 1 million characters long. Like I actually, as a kind of troll, implemented a replacement for npm semver that replaced numbers with like the written out word, but like as one gigantic regex that was I think like 3 million characters long or something like that.
So for April Fools.
Don't
right?
do that. Only do it for April Fools.
All right. Another question. If center row back.
Yeah, so when you were preparing this, did you run into any like ambiguous generation things that take sometimes has?
Ambiguous generation things. Yeah, it's fairly easy to do that. Generally, when you're writing with a parser generator, and you have like multiple options that a thing can parse. Like here we have the like 1 to 9 digits and 0 to 9 after. So if I like actually did the 0 to 9 first, like that's if this is a 1, it's going to match that and be done. It's not going to try and consume any more numbers because the first one matched completely. So you sometimes have to like switch the order around of things. So yeah.
Cool. Last question before we wrap up. Question time. I see a hand in the front. Go for it.
I taught my computer how to do it for me. I actually wrote like a sequencer thing that I'm just pressing like 2 keys and it. Yeah, like here. No hands. That's a little presenting idea thing I've been experimenting with.
Cool. I think sorry.
Just wondering, when you were writing the rules, there was no, usually there's a top-down kind of order, right? But for this one, you sometimes define something after, sometimes define it before, stuff like that. So I'm wondering how that compiling of this file works, and how does it know where to look for the subcomponents and where to find them? Do you know anything about that, or? Because, like, for example, you wrote expression here and then values below it, but then sometimes things that you're referencing at the bottom are defined at the top, and sometimes it's the other way around.
Yeah, so internally the order doesn't matter. It's only for like the external entry point of the parser. It will point out whatever the first rule is. So in here it's going to hit the expression parser whenever you try and run like this parse function. And then that like internally will do something. Like I could delete that and like there's all these other like totally valid parsers here, but if I try and like parse anything useful, it's going to be like, nope. No, value's not defined. that doesn't match anything, but that does because that's the white space, and that's the only rule that is allowed now. So it. No, it's. That's just how the parser generator works. It just grabs the first rule. That's generally how these ones work. Well, it's just the first one that matters, and then, like, inside of it, it doesn't really matter after that. It'll just grab the first rule and label that as, like, the top-level parser, and then inside of that, you can, like, reference all the other named parsers to do whatever you want.
Cool. Okay. That's the end of question time. Stephen will be around, I think, after. So while we're milling there, you can ask more questions. You can also do that of Yorman, I think, if he's going to be hanging around. Or Twitter. I think their handles are on our stream. So thank you, Stephen. Another round of applause, please.